Welcome, welcome everyone. Thank you so much for joining. My name is Darlise, aka Darveloper, here on the internet. I'm the developer marketing manager here at Devpost. For anyone who's newer to us, Devpost's mission is to inspire developers, creatives, and builders to build great software. We're creating a world where everyone who wants to improve their craft or to be inspired to build comes to Devpost for that inspiration. So, to that end, we power most of the world's software hackathons on our platform. Quick context in case you're getting oriented, maybe you're just joining this particular hackathon. Agentic Cinema is a hackathon from Google Cloud Partnerships where you're building basically a functional AI agent powered by Gemini and Google Cloud Agent Builder that solves real bottlenecks across the entertainment and media world, leveraging technology from our various partners. Today's partner, we'll be speaking with Parallel. Parallel is going to give an amazing workshop, kind of like a demo slash Q&A. And so for the agents that you're building, think filmmakers, think screenwriters, think studio crews, think fans in terms of the solutions and the agents that you'll build. Submissions are open through, I believe, September 9th. So if you're not registered yet, this is a really great time to register. Hopefully this workshop, this demo, this session convinces you to join. If you're already joining, hopefully this pushes you to the next, kind of stage in your build. This is, I believe, our fourth session this week, one for each partner track. Today's is with Parallel, so I'm happy to introduce George and let him take it away.
All right, all right. Thank you so much. Can everyone hear me? Okay, can you give me a thumbs up? Or just to see if anyone's paying attention? All right, we got one. We got one. Cool. Thanks so much. Before I start sharing the screen, I'll just give a quick intro about myself. I'm George Pickett. You can find me, George Pickett, on Twitter. I post a lot about agentic engineering best practices, Codex. I love using Codex as my daily driver for programming. I'm a Codex Ambassador, which just means I run events for Codex here in San Francisco. Also, yeah, based in San Francisco. I grew up in the East Coast, grew up in Florida, a little bit north of you. And yeah, I'm excited to be here today and show you guys how to use Parallel and yeah, get you excited about building on Parallel. I can share a link. I saw someone ask about the link already, so this will spoil the demo a little bit, but hey, go check out the link. So, yeah, a little bit more background on me. I'm a self-taught developer. I taught myself programming in 2014, and at the end of 20 or the beginning of 2015, I moved to San Francisco. No job, very little money, and I just put myself on GitHub, put up a personal website, and just started applying to startups. I've worked in mostly startups throughout my career. I was started in front end, went to more full stack, and now I'm doing developer relations. Um, yeah, I really think you guys are in the right place to be here doing a hackathon. It's such an awesome way to learn. And yeah, if you don't have a team, I'd highly suggest getting a team. Building with other people is the best way to learn. Um, and yeah, I'm happy to answer questions throughout this demo about Parallel, about really anything, about how to build, best practices, anything like that. And yeah, with that, I will just share my screen and walk through everything. Cool. Y'all can see my screen okay? Good stuff. I'll take that as yes. Cool. So just from a high level, I mean, maybe it just makes sense to pop into the demo. So from a high level, what Parallel does is we provide search to agents. So if you think about what an LLM is trained on just the knowledge, like basically a frozen set of knowledge. So if the training cutoff was January 1st, 2026, and you wanted to ask it about the winner of the World Cup, it's either going to make something up, which is not ideal, or it needs a tool. And the tool in this case that we're using is Parallel. So there are a multitude of search providers you can use. We all basically index the web, and you can plug these tools into the LLM to give you live grounded results. So that's what we're doing here. I have two examples. One is with Gemini grounding, and the other one is just a pure parallel search. So the difference between these two demos, I'm gonna just switch between the tabs a little bit and also happy to answer questions along the way. Sorry, I'm opening up the chat so I can see. But yeah, I'm going to switch between these two demos because they work a little bit differently. So this parallel search API, in this example, we have this SDK called Parallel Web, and you can initialize. Actually, before all this, if you're kind of confused about how any of this works, you can literally just give your agent Parallel's platform website and just say, "Hey, help me make a basic search integration." And before you get started, you need to go into your Parallel platform and get an API key. Once you set up your API key, you'll get some free credits. I think like if you put your credit card in, you'll get at least $5 in free credits. And with our pricing is, let me open this up. Our pricing is $1 per thousand queries. So $5 in credits is pretty insane. 5,000 queries. Like it is hard to make 5,000 queries. It's quite a lot of money. Um, this is an introduction to or it's an announcement we just had today for Parallel Search Fast, which is super exciting. Just going to show you. So artificial analysis basically gives they basically rank AI products and LLMs based on performance. And usually it's just about like coding agents, image generation models, intelligent speed and cost per task of like frontier models. But they just released this one this week about Search API benchmark, which is super cool. And you can check this out on your own. But the long and short of it is that Parallel is the cheapest, the fastest, and the smartest. Whether you're using like our advanced search or our fast search, really good options here. So I'm going to switch back over to the demo. And so out of the box, when you use our SDK, if you get an API key and you set up the most minimal possible code snippet, like I have here, what you're doing is you're going to make a query. So this is hard coded here. But basically what you do is you give it an objective and you can think of this objective as like guidance, kind of like guidance, like a prompt you would give an LLM. So you're going to give it an objective and then search queries. So our recommendation is that you give it three search queries, kind of spanning different topics. So instead of just saying the same thing in the objective and the search queries, you want to kind of make them diverge a little bit to sort of cast a wider net. Just checking the chat. Okay, cool. Team search. Um, yeah, so the idea is when I make this call here, there's no LLM involved like we're going to experience with the Gemini example. So I'm going to press search here. And basically we're going to get a list of URLs and excerpts. These excerpts here are actually truncated. I think they're up to, don't quote me on this, I think 5,000 characters. But basically what we've done is Parallel itself has crawled billions of web pages, like you can kind of imagine Google has done, and then we extract the sort of the important information from a website. So if you were to just make a network request and say, fetch the information from whatever, techcrunch.com/article ID, you would get a lot more than just the contents of the article. You would get ads, you would get links, all this stuff. So what we've done is we've kind of crawled the web and extracted just the relevant stuff from each web page, so that when you make these searches here, what you get is you get really clean results. And that's important because you're not feeding your LLM a bunch of junk. So when you make this objective and this search, you get a bunch of results. And it's then passed to your LLM to consume to actually do something with it. Um, yes, it's exactly. Yeah, Exa is the second biggest player in this space. So there's like Exa, Firecrawl, Tavily, these guys. We actually have them on, or this isn't us. This is artificial analysis that made this. But you can see here, there's like, kind of time per task, how long it takes. There's a cost one. Let me see. Yeah, cost per task here. So instead of just measuring like speed alone or price alone or cost alone, they sort of define it per task. So you give these, they have these benchmarks where, they don't tell us the answers to them, and then they run all these, so you can kind of see performance here. Um, So when you sign up for Parallel, everyone gets $5 in credits. So if you go to parallel.ai, put in a credit card, you'll get $5. I think there are some cases where if you're a startup, you'll get $80. But yeah, feel free to add me on Twitter and DM me if you're building and need help with credits or anything like that. Um,
I see one question in the Q&A. How different is this from, let's say, a search engine with an ad blocker? This might be a newbie question, but I'm trying to understand the use case of Parallel.
yeah, totally. So the use case is actually a better example is if you go into here. So in this example, we're using the Gemini Flash model. So if you're building an agent and you're building, let's say you're making like I don't know, you're making a tool for filmmakers to make like historical documentaries or something like that. And you want to make an agent that helps them research like I don't know, the factual correctness of whatever the movie they're directing. You can make a deep research agent, and when you make this agent, it doesn't natively have the ability to search the web. So as your agent is progressing, you might ask your agent a question like, tell me about the railroad industry during the Civil War or something. I guess that's not a good one because that's probably in the training data. But when you're asking maybe about like, finance data or anything that needs the live web, you need to search the web in some way. And an LLM or an agent doesn't have that ability. So you have to give it a tool that can then search the web and then provide those answers back to the agent. Um, so yeah, the general flow with building agents is the agent is reasoning and then it decides that it needs to search the web. It calls on a tool that you provide it with, in this case, Parallel. Parallel does some web search and then brings results back into the agent, and then the agent can reason over those results. So the example of like an ad blocker, it wouldn't really like you wouldn't really be able to plug those results into an agent. So really what we're doing here is making it really easy for agents to consume the live web data. I'm gonna go down. I think there's another question. Why do I need parallel? Was it different for which use cases? Yeah, use cases for I mean, if you've used any of these, actually one use case for parallel is if you use Claude or Codex as your coding agent, you can swap out the Claude search for parallel search. And in my opinion, you'll see some improvements in your ability for your coding agent to give you accurate results, like accurate documentation, updated documentation. Same with Codex or Cursor. OpenClaw, Hermes, any of these open source agents as well, you can plug in parallel. And it's crazy easy to do this. I'm gonna just go to our site here. Um, if you're using Claude, you can literally just copy this. And this is different actually than what this hackathon provides, in that it's not using our API, it's using an MCP. So if you install this in your terminal or this for Codex, it will install this MCP server that your agent will be aware of. So then as you're doing your coding tasks, or any kind of task, not just coding, if it's something that your agent determines needs web search, it can search the web. And the rate limits here are pretty generous. I think it's like 1,000 searches per day. Um, but yeah, that is that. So the difference between these two, I'm just gonna make sure I don't have any questions real quick. Oh, there are 5 new ones. Um, can't you do the same? I don't know if that one's for me. Um,
Yeah, these are mostly chat. We can keep going.
Cool, cool, cool. Yeah, yeah, maybe just let me know if there's something
I got you.
you can monitor the chat. Yeah, so I think like a lot of the confusion about parallel is like when do you need parallel? And I think the answer is it's when you're building an agent that needs anything that's outside of the training data of the agent. So in this case, what we're doing is um, the Gemini, the Gemini API has a plugin. We've made a parallel plugin for the Gemini API. So out of the box, it would use the Google search, and that's fine. But there are multiple ways to do the same thing. So parallel search is it's really optimized for LLMs, and we've indexed the web just like Google has done over the last 25 years. Um, but this is the tool you can give to the Gemini agent. So you ask a question, and then Gemini decides, okay, this like since I'm asking about latest updates, the Gemini agent determines, hey, they're asking about latest updates. So what I need to do is I need to use the tool that's provided to me. And in this case, the tool is Parallel. So then Parallel will do its searching. I think behind the scenes, this shows the evidence that was returned. It's a little truncated, but basically like you make your query to Gemini, and then Gemini says, "Oh, they're asking about latest news." So then it calls the Parallel search tool. Parallel will get a bunch of results, and those results are optimized to be fed back into Gemini, so Gemini can reason over those results and then provide an answer. So the difference between this example and the search API example is in this Gemini example, there's an LLM and there's an agent behind it. In the search API example, let me just open a new tab so I don't wipe my results. In the search API example here, we're just making an API call and then showing you the results from the API. So behind the scenes, Gemini is doing this. This example is just a little bit more pure and more simplified to make it sort of easy to understand. And just one other note, we have some best practices in our docs about how to formulate this objective and what to pass into search queries, which I mentioned before. So in this sort of constructed example here, it's really, really simple. We have a hard-coded objective and hard-coded search queries. But the way you can think about this is your agent is going to be writing this code, literally exactly this code on the fly as it goes. So going back to, oh, did I close the other tab? Drink. Going back to this one, when you ask this question to your agent, if you're using the Gemini example, your agent will write this code and perform this search. But the difference is all of the results here get fed back into your Gemini agent. And then this here is the synthesis of your agent seeing the results from Parallel and kind of reasoning over them and deciding what's important and then printing it out. So if this Gemini agent here didn't have Parallel web search, it wouldn't have necessarily access to the latest product updates. And one differentiation here, you might be thinking like, oh, why can't you just do this? I'm going to search Google for what are Parallel's latest product updates. And that's fine, but when you're creating an agent, it's not the same as a Google search. So you need to kind of, give it tools. Um,
One
I'm gonna,
question in the chat.
yeah, let's
Oh,
go for it.
yeah. So George, no, not George. Surya is asking, you're George. Surya is asking, I'm building a waitlist hunter AI agent that monitors restaurant waitlists in real time. For hackathon projects like mine that need reliable web grounding, what is the best practice to avoid hallucination when restaurant wait times change quickly? Should we prioritize parallel search over Gemini's built-in grounding?
Yeah, that's interesting. I think it's a really cool idea. I would say that it's actually not the best use case for parallel. So if you think about it, I'd be curious. Maybe I'd be curious, number one, how far along are you and where are you getting the waitlist data for? I don't have an intuitive sense of where real-time restaurant waitlist data is. I would imagine it's in what's like OpenTable or something like that. I think there's an API for OpenTable. So, like, in case you're not familiar, OpenTable allows you to go and make a reservation at a restaurant through an app or maybe through the web. And this kind of data, like was mentioned here, is changing it's changing like maybe on a minute by minute basis. This isn't the type, like, at least in 2026, we're not quite there where Parallel has a perfect index of like every API. So we don't have to my knowledge, we don't have live data from OpenTable. What we would have more likely is like, I could ask like what is the price of Bitcoin or something like that. Like we have more general web data that's considered live data, but we don't like the idea that we would have like a minute by minute update to our entire index of billions of pages. It's just not quite the right use case here. Someone else asked, asking about the idea that Parallel does better than Gemini's built-in grounding. Um, yeah, what I would say is try it out and build it, and I think what you'll find is that your results from Parallel are going to be better, more accurate, more up to date, and faster and cheaper. So this is especially important when you're building agents where cost is important. Parallels, it's $1 per thousand queries. So your agent you can just test it a ton and you're not even going to spend $1. So I think that's one of the most compelling reasons to use Parallel is when you want to do something that's really high volume. And then like I guess aside from all of this, we have some other APIs. We have a like deep research APIs and one called the Monitor API. The Monitor API, you can kind of curate your own data set and then like monitor changes. It's kind of interesting. Um, cool. We have, yeah, happy to answer any more questions here. But yeah, I think it's relative. I mean, sometimes things feel obvious to me, so I'm super happy if anyone's unclear about how this works. I think there's also like this space is very new, agents are very new. So just understanding the flow of like, okay, when I go and ask an agent a question, like what is happening behind the scenes, I think that's something that people are often confused about. And yeah. Okay. Where can a novice start to build a lean MVP this weekend? The documentation, the videos, the books, any idea is welcome. Um, I'll go on the one before that, it doesn't return images. That's something we don't have right now. And then yeah, another George, hello, other George, asked me about building an MVP. I would suggest, I mean, it depends what I would always use a coding agent. So for me, I am literally never typing code by hand these days. I'm writing prompts to my agent. I'm giving my agent docs. I would literally just go to get started. In our docs, we have an agent onboarding. So you can just copy this, read parallel.ai/agents.md and set up Parallel. I should have actually started with this. This is like this is the easiest way, and this is sort of becoming the standard way to get started. So when you do this, I can go and click here. Basically, when you copy this block here, your agent is going to go and read this agents.md file, and these are instructions about how to set up our CLI. So if you give this to your agent's going to know what to do. It's going to install the CLI. It's going to ask you for an API key. I think it will even like test it out to make sure it's valid. And so by running just this and giving this to your coding agent, it'll configure your CLI, make sure you have your API key set up. You do need to go into the parallel platform and create an API key before your agent can actually do this successfully. But as long as you have an API key set, and you run this, what, 12-word command, you'll have parallel set up and you can start building. I would say start with the parallel CLI and like the simplest possible like Next.js or React.js app and just create what I did here. Do a little box with a question and then, send it to parallel and have it show the results. And so I think like step one is to just connect your API. You need to get an API key, copy the agent onboarding, and then just prove it works on your own machine. Because if you don't do that, you're not going to be able to get started. But once you set this up on your machine and if you can run this on your machine, then you're basically ready to go and you can start building an app that does all kinds of cool stuff for this hackathon. So I would suggest getting the CLI set up, get your API key set up, get to the point where you can actually make the API call here with Parallel. And then once you're able to do this, you can start feeding your agent different queries here, and then you can inspect the results. And I guess the distinction one more time to lay out the difference between this example and this Gemini grounding example is this Gemini one is configured already with Gemini and there's an agent, there's an LLM behind it that can actually write code. Whereas this search API example, all it is this snippet which outputs what I have above and it feeds everything above to your agent. So my suggestion again was to get started with this, make sure you can call the API, and then once you can, give it instructions like, hey, wire this up to Gemini or, perform whatever kind of task. Let's see.
All right, we got quite a few questions in the chat.
Yeah,
The
sure.
one right after the one you just answered says, this is from Keith. For media and entertainment pre-production workflows like location scouting or permit verification, what search objective or query formatting produces the most deterministic results from parallel?
That's a super interesting question. I'm gonna read it again just so I can make
Hmm.
sure. Um, for media entertainment workflows. Oh wait, I missed it. Oh. Okay, sorry, I actually can't find it. Can you just repeat it?
I'll repost it. Yeah.
Oh no, I
Um,
got it actually. Oh, what search objective? Um, cool. Location scouting or permit verification. Off the top of my head, this sounds like information we will have indexed. I'm curious for you to try it out and see if you get what you need. Honestly, when I'm like, so when you're setting up your agent, like I am never, if you see this objective here, find the latest information, blah blah blah. This objective in this case was hard coded by me. But when you're implementing parallel into an agent, your agent is going to be writing this objective, and agent is going to be writing these search queries. So I think the best thing, oh, maybe this is relevant actually. Like what I would do if I was finding, you were saying location scouting and permit verification. So what you might do is you might find the exact websites that have the permit, like the source of truth for these permits you're talking about. I have no idea what this is, but like presumably when you do a web search, it's gonna find something about these permits. You can actually restrict the domains using some extra parameters in our API. So if you find a source like this permit website or something that you want to restrict it to, that's a really good way to make sure like when my agent makes this call and the call is related to these permits, it's going to restrict it to just that domain. Um, and yeah, I think that's cool. Let's see. Someone said it might be useful to highlight features of parallel with strong and complex use cases. Um, Yeah, let's see. So, I mean, we have a few different I should have just kept one docs page open. So we have different modes in our search. So we have like our fastest search is called Turbo, and Turbo is like when you use it, it's actually mind-blowing how fast it is. 200 milliseconds, it's like crazy, crazy fast. So one thing I've done just to like outline when you would use these different modes is that Turbo would be pretty much like for voice agents. So if you're building some kind of voice agent where you want to ask questions that would require the live web, Turbo is the mode to go for. It's not quite as smart as the following modes, but it's still pretty smart. And if I would say the most obvious case to use this is if you have something that's super, super low latency, like a voice agent, where like speed is really important. If you can wait up to 700 milliseconds, that's the speed of fast mode, then this is probably like the best balance. It's also super, super cheap. So fast mode it's quite a bit smarter than turbo, and it's close, maybe not quite as smart as basic. Um, and then yeah, if you have something where yeah, it's like a research pipeline or not quite deep research, but something that's like you just want to make sure your results are as accurate as possible. And, waiting 3 seconds isn't a big deal, then advanced is your best option. This is our highest performing search mode. I think there's something. So yeah, this is sort of an overview. I mean, I kind of mentioned this before, but like the idea is if you give it 3 to 6 search queries, and someone asked about how to write objectives, I think like I would literally just give when I'm building my hackathon project out, I would give it this documentation and just say like, I would build the MVP of my app and then I would go back to the docs and I'd say I'd copy the docs, I'd give it to my agent, and I would just say, hey, double check Parallels docs and make sure we are writing really great objectives based on this use case, and make sure we're doing search queries right. One failure mode I've seen that's common when you just ask an agent, hey, build this, with vague instructions, is that it will just give it one search query. But this is actually, if we go back to the example, oh, my dev server died, it looks like. Um, I have no idea why. Um, but yeah, that's that. Let me see where we at with questions. Okay, another question. If Parallel is optimized for agents, how does it avoid returning fake data that can cause hallucination? Yeah, no, that's a really good that's a good question. It's about basically trusting the results. And I think the idea here is like you might have there's a lot of crap on the web. People post all kinds of junk on the web. And as we've built out Parallel, so we're not just crawling the entire web and then weighting every web page equally. Like, for example, if there's like hate speech or porn or like anything that's really offensive, like that gets massively downranked, if not entirely excluded, likely excluded from our index. And then our entire job as a company is to look at the web and contextualize it and make sure we're finding the most relevant information. So it's been we're up to 100 people now. We have something like 60 engineers. Just incredible talent here that's built an index in 2 years, an index of the web that's performing we're basically the most accurate, the fastest, and the cheapest index out there. So I think the if you're finding hallucinations or like incorrect results, we would love the feedback. We're always hunting for the hard and difficult cases. I think you'll find if you wire up Parallel to your agent, it's just going to be right. That's my experience with Parallel. I plug in Parallel and it just returns the results I'm looking for. Um, cool, cool, cool. That's an interesting question. If you can build in the cloud if you have no local computer. I know there's a way. Um, I don't know if you're going to be able to build your whole hackathon project in the cloud, but like Cursor has cloud agents. Um, yeah, there are a hand ChatGPT work, I think can do work in the cloud. Will the judging environment, I'm not sure what Ruthie's asking about the judging environment simulating high concurrency traffic. Um, cool. Okay, a lot of people on 30-minute plans.
We do have a question about projects themselves. So basically, it was stated, Gutham is saying, it was stated that our solution has to be for the media and the entertainment workflows. So can you give some inspirations around, I guess, what to build? So Gutham is wondering, can they work on a general use case where Parallel fits in the most, even though it may not be specifically for media and entertainment workflows?
I mean, I'm a little less familiar with the whole media I mean, I could just riff and kind of make up some ideas for hackathon projects, but I'm not quite sure on like all the use cases. I think like the yeah, thinking about like the tools that like a film director or like screenwriter would use would be an interesting use case, but um I'm not totally sure if I can help on that answer.
Ruthie is also asking optimal batch size for parallel calls before performance degrades.
Um, where is that one?
That's past all the basic otter 30-minute plans.
Okay. Optimal batch size. I'm not sure, like generally the way to use parallel web search with agents is you just give your agent the tool and it's up to your agent for how to use it. Like generally you're not making like if I go back, let's hope that this dev server restarted. There we go. Um, generally you wouldn't make like 20 of these calls side by side all at once, if that's what you mean by batch size. Like generally you would just feed your agent something more like this. When it needs search, it will make searches, feed it back to the agent. Your agent will reason over the responses, give you an answer. Um, if what you're thinking is something more like a deep research agent, it might be more interesting to have your agent formulate like 20 of these and just perform lots and lots of searches. Um, I don't know if there's really I think the optimal batch size would depend on um, it would depend on your use case. So, okay, I see your next question. But yeah, I would think of it like this. If you're asking a simple question like this, like find the latest information about this company, focus on product releases benchmarks, you're not going to benefit by doing this times 20. Like there's only so much information on the web about Parallel's latest releases and products that one search is going to give you everything you need, and you'd be wasting your time and money to try to do more concurrently. Um, however, if you are doing something like if your query is really vague, like maybe you have something you're like, I want to find really unique film directors, for example. Like let's say it's something like that. What you might do is you might, and when I say you, it's probably your agent doing this, but if you have a query like find like unique and inspiring film directors, you could you could set this up in a way where you would make like 20 of these API calls where you'd say like best film directors in Arizona, best film directors in Belgium, best film, you know what I mean? So it's like the idea is that you're fanning out and you're making like a really wide search. Um, I think that's an interesting use case and maybe even underexplored. I'd be actually curious to see people create um, create use cases where they're doing lots of searches that are exploring in a really wide way. I think that'd be kind of interesting. Um, okay. Another question says, you mentioned Parallel might not be suitable for minute by minute data like restaurant wait lists. What is the average freshness or update frequency of the index for general news, tech updates, and industry entertainment data? Um, I'm not, I don't have a perfect answer for you, but something like one day, like I think you can imagine or you can expect that you'll have data that's like if something happened yesterday, it should be in the index. Um, but yeah, something like live traffic data or restaurant data, I think you'd be better suited to use an API for that. Um, Partial failures if 2 out of 10 API calls drop. Um, First, I've never seen 2 out of 10 API calls drop from Parallel. Or I can't say any. I'm sure I've had failed API calls, but it's our uptime and reliability is pretty good, so I wouldn't worry about that too much. And Ruthie, it sounds like you're more technical. I would, in my case, if I was having a question like that, I would instruct my agent something like if you're really worried about like recovering from failed API calls, I would instruct your agent, like your agent is going to be handling this anyway. Like it's unlikely that you're using this code snippet on its own. So your agent is going to make a tool call. It's going to search the web. Let's say there's a failure. I think if you put a simple instruction to your agent, like, hey, if you get a failed tool call, try again, something like that, it's going to be fine. Also, the API is pretty fast, so if you set a time, like if you're using fast mode, which is 700 millisecond response time, you could set a timeout like 2 to 3 seconds, and if your agent doesn't get a result in 2 to 3 seconds, you could tell it to retry. Um, let's see. Um, does using okay, can I use parallel search providers pricings like location, rent prices, or assets in e-commerce? That's interesting. You know, Miguel, I'm not entirely sure. I haven't tried that. I would say like one for if it's $1 for 1,000 searches, like just give it a try and see what it says and then verify against, whatever you see. Oh, that's it. Roshan is asking which LLM Parallel is using for the search. So this is an interesting question, and to answer this question, it's like there's a lot behind the answer because when Parallel is making when you make a search to Parallel, you're making an API call with a query like we have here. And you're getting a result if you're using turbo mode in 200 milliseconds. So your I guess the short answer is that we're using a variety of smaller fine-tuned models to serve it really fast, and we're using slightly larger models to create our index. But I think that's sort of like the secret sauce of Parallel, which I cannot reveal here. Um, I'm not sure. Do you recommend using grounding with Google search inside parallel threads? I'm I'm not sure how to answer that. I can write that question down and get back to you. Payload, okay, what's the maximum payload size per request? Um, Also not quite sure how to answer that. When you say payload size, you might be asking objective and search query length. Um, and I'm For the objective, the maximum is 5,000 characters. For search queries, a maximum of five search queries, 200 characters per query. Okay, I'm gonna go. Can we target specific top level domains? Yes, you can. And let me go to advanced settings here. Um, doo-doo-doo. Yeah, so if you look here in source policy, you can um there's a configuration option called include domains. It's kind of like an allow list. And actually what I did in my example was I don't know why my dev server's dying. No, actually I didn't restrict it here. I thought I did. Oh yeah, and in this one in the Gemini example, I did restrict it because I just wanted to make sure that like if I'm giving an agent the ability to search the web and it's for a demo, I want to make sure it's restricting it to just our domain. So if you find domains that have authoritative information that you like and that makes sense to you, put it in this array called include domains. I think that answers Ernesto's questions. Okay, someone, I built a knowledge assistant using LangChain, Gemini. Okay, I'll read it. But managing custom scrapers for real-time data was quite the bottleneck. If I integrate LangChain parallel into this workflow, does it eliminate the need for maintaining my own scraping and embedding pipelines for live data? How seamless is the context handoff? Okay, I'll start with a final question about how seamless the context handoff is. It's very seamless. So if you imagine if you imagine giving your agent, imagine you ask your coding agent to look at a markdown file. If you just tag a markdown file, you say, "Hey, look at the README and then explain it." When you do that, the latency is extremely low because it's local to your computer. If you're using turbo mode, imagine it's just like that, but adding 200 milliseconds. If you're using fast mode, same thing, but 700 milliseconds. Basic, about a second. So, in terms of how much time is added to my whole agentic stack, it's pretty low and it's pretty incredible how fast it is. 200 milliseconds for turbo is sort of crazy. Um, but yeah, the handoff is seamless because you're basically just the results that Parallel is handing off to your agent is optimized for LLMs. It's markdown, it's cleaned up. It's not this random web data. It's really like clean and precise um, text. And then you're asking, so yeah, it sounds like Saman, it sounds like you have a pretty sophisticated custom web scraping for real-time data. Yeah, I mean, real time is it's a relative term, I guess. Like when you're talking about restaurant wait times, for example, or live traffic info, that's truly, truly real time. Um, it parallel is not, it's sort of not the use case we're building for. But when you talk about um, giving fresh data to agents, and freshness might be like a few hours to a day old. That's pretty fresh in terms of LLMs, since LLMs are only trained, every 3 to 6 months or a year. Um, so yeah, I don't think it depends. I don't know your exact use case with this scraping stuff, but I imagine that there are parts of your pipeline that could be replaced with parallel, but I'm depending on how real time your data needs to be, I kind of doubt that you could just replace the whole thing. Can we have, oh, that's an interesting question. Ernesto asks, can we give different sub-agents with parallel tools and have specific source policies for each one? That's cool. That is really cool. I love that idea, actually. Um, so it depends on your agent harness. I'm kind of doubtful that with this, like you definitely can. I guess the short answer is you can. Um, that question comes down to the configuration of your coding agent or whatever agent you're using under the hood. If your agent framework has the ability to define tool calls for subagents, there's no reason why you couldn't. So one, just like the craziest example I can think of is, imagine with this example I had about finding interesting and unique film directors. Imagine you had 50 subagents set up for all 50 states in the US. You had a Florida, Georgia, South Carolina, whatever, subagent for every state. You could potentially ask a question like, find me the most interesting and cool film directors from your main agent, and it would spin up 50 subagents. Each one would call parallel and feed it back to the main agent. I'd be curious to see someone try it. I haven't tried that, but super interesting use case. I have a platform that pulls from Internet Archive API to present pictures and text. I I need some clarification there. I don't quite um sorry, I don't have an answer for that since I don't quite understand it.
No worries. Okay, so we're like 2 minutes from being at time. I want to say thank you everyone for all your questions. These were a lot of questions. I wasn't expecting all of this, so this became a full-on Q&A, but I love to see it. Quick question for you, George. If people have additional questions about Parallel, what's the best way to ask and get support?
Totally. I'm in the Discord, so feel free to message me in Discord. Please mention that you're from the hackathon so that I know I get random spam and scam stuff on Discord, so let me know. Discord is cool. Also, Twitter. I'm on Twitter all the time. That's where I live. So follow me on Twitter, hit me up on Twitter. It's just George Pickett on Twitter. Happy to chat there. Happy to help you out. I'll be judging, so I'm the right person to ask. Hit me up, and I'm happy to guide you in the right way.
Amazing. Thanks so much, George. And thank you so much to everyone who attended this session. One final thing before we all kind of clock out of here. Please, please, please fill out our survey. This kind of lets me know how this session went. I hope you all enjoyed this. I hope you all got your questions answered. And like we said, if you have any additional questions, you can ask in the Discord, find us on X, find us on Twitter, find us everywhere, essentially. But please, please, please fill out the survey. That kind of helps us bring more sessions like this to you all. Where is it at? I'll put the survey right here. Thank you so much. And I hope you all have a great rest of your day. The next session will be next week, Monday. So if you haven't seen the registration link for that, it is also in the Discord. I cannot wait to see everyone's projects and have a great rest of your day.